Introducing the 2022-3 Schrödinger release. Let's briefly explore some of the new features and enhancements. In Maestro, we see a powerful new approach to apply atom styling and molecular representation changes to selected entries. This allows for a large collection of selected entries to be styled without needing to include each entry in the workspace or to run custom scripts. Let's walk through some of the features in detail. Like the Style Toolbox, used for styling atoms in the workspace, styling selected entries offers the same layout of buttons and menus, which for now are limited to controlling atom visibility, molecular representations, colors, and labels. With this example of 1000 entries selected, let's hide nonpolar hydrogens, show as ball and stick instead of wire, and color atoms with custom carbons. And there we have all 1000 selected entries with the same style. At no point did we need to include any or all entries in the workspace. Now, by default, changes are applied to all atoms in each entry, but this can be fine-tuned with the scoping menu, which offers more specific objects. Let's take another example, this time with 10 protein ligand complexes as our selected entries. Here, let's show only the binding site atoms within 5 angstroms of the ligand, style the receptor in thin tube, colored by element. Let's hide nonpolar hydrogens and display residue labels. And then for the ligand, let's set it to ball and stick with magenta carbons. And now, all 10 entries have the same style. Styling atoms in selected entries is available here from the entry list or from the right-click menu of selected entries. Among the various improvements across the application panels, let's start with the FEP Plus panel. Here we see a new tab called Groups, which organizes together ligands represented with different states, namely protomers, tautomers, and conformers. So in this example, we see grouped in the first row is a ligand represented by 2 states. We can see this in the workspace. They represent 2 conformers, where the ligand is flipped. This next group represents a protomer pair. Again, if we view them in the workspace, we can see the 2 represented in their protonated and deprotonated states. The next group is another protomer pair, and now this group represents a ligand with 4 states, 2 of them as protomers and 2 flipped ring conformers. Apart from nicely organizing the states into groups, one can also manage pKa and tautomer corrections. Here one can specify the default pH value, or double-click to edit the groups, solvent pKa, or protomer population in solvent. Now, to get the solvent pKa's, one can either look up the experimental data or run an epic pKa calculation, which is what we have here in this example. The 4O compound has a pKa of roughly 9, 4F compound is at 915, and the 4E compound is at about 8. So let's manually add these solvent pKa values into the FEP Plus panel. For the 4O pair, it was about 9. 4F was 915. And for 4E, it was at about 8. Now note that after the solvent pKa information is entered, the complex population is automatically calculated according to the FEP Plus predicted delta-delta Gs among these protonation or tautomer pairs. Now, before we apply these corrections to the map, we can first take a look at the correlation plot, which, as we can see, is not ideal, with an R² of 0.21. So now let's apply these pKa or tautomer or conformer corrections to the map, and then revisit the correlation plot, which has now improved. Elsewhere in the suite, users can narrow down specific interactions in the protein interaction analysis panel by applying a filter. These filters include residue types, non-bonded interaction types, and interactions within a set distance. And speaking of interactions, Maestro now supports sending all non-covalent interactions that are visible in the workspace over to PyMol using the Send to PyMol panel. Over in PyMol, the interactions are grouped as separate objects. Back in Maestro, other small enhancements include a new workflow action menu for protein-protein docking workflows, revealing a collection of useful tasks for analysis and follow-up steps. And finally, over in nime, we see new nodes to build and apply machine learning models with deep AutoQSAR. The configuration settings have a similar layout as the panel in Maestro. This is just a brief look into the 2022-3 Schrödinger release. As always, for the complete list and to learn more, visit schrodinger.com/new features.